Let's talk about the top 5 reasons to bin pick. When your part presentation can't be changed upstream. I've had a lot of conversations where we say, okay, this is pretty straightforward, but my parts are dumping out in a bin upstream and it's an extruding machine or something, for example, and I can't really slow down the process, or for whatever reason I'm constrained upstream and I can't change how the parts are presented without having an intermediate step where someone literally just spends a bunch of time staging parts, right? Bin picking fits in really well there. When flexibility is more important than cycle time. I haven't talked about cycle time yet, so let me do that real quick. Cobots, like I said, are meant for mimicking human capabilities, right? So there are certain situations where you have a cycle time of like maybe a second or two. Not really a great ballpark for a cobot to be in. Every once in a while, your stars might align perfectly and you can get away with it, but in most cases, a good rule of thumb is 4 or 5 seconds for a collaborative robot. And actually, with the amount of data and numbers the camera needs to crunch every time it scans the bin, a couple seconds is good there too. So if you can afford anywhere from 1 to 4 seconds to figure out what the next pick is going to be, that's great. You can actually do things, you can be clever about programming it, like when the robot picks apart and moves out of the camera field of view to do whatever, the camera takes the part then, it cuts your cycle time significantly to do that. Main takeaway for point number 2 here is that if you need to be super consistent with your cycle time, so I need my cycle time to be anywhere from 3.5 to 3.7 seconds, or even honestly 6.5 to 6.7 seconds, right? You're not going to get that tight of a window of cycle times with a bin picking system. Just because your part density could change, your part orientations could change, certain bins, even of the same part, could take another fraction of a second for the camera. You can certainly get within a window, but cycle time is not the something that we chase with the bin picking system. It can be optimized, but yeah, flexibility is the name of the game here. High part volumes. This kind of ties into part presentation upstream. The higher your part volume, the more, depending on your process, right? The higher the part volume, the less likely it is that you can afford the time to stage parts individually. So at the very least, vision becomes an attractive option, whether it's 2D or 3D with high part volumes. If your part volumes are high enough, the most cost-effective thing is just to dump them in a bin to feed them into your next process. That's where bin picking obviously really shines. Multiple SKUs, I've kind of talked about this. Each SKU mechanically would need probably custom tooling. One bin picking station can handle several. As we discussed earlier, there's not really, the upper limit's determined by really you, not technical limitation in a practical sense. High value parts, we'll talk about this in a little bit, but just with automation in general, if you have a $10 part that you're producing 10 of, you have a $1 part that you're producing 10 of, and you have the budget to automate one of those processes, which one of them pays for itself quicker? It's that $10 part, right? Because every part you complete is a bigger chunk of value that moves through WIP. So high value parts in general tend to pay for themselves very quickly, or it just in throughput, and especially so with bin picking.